Hi, hello. My name is Muhammad Aifiq Haikal bin Abdul Rahman, AF160252. Today, I want to present my geosynthetic project, which is design and application of geosynthetic in unpaved road. First, I want to explain about the introduction. What is the unpaved road? Unpaved roads are usually used as a temporary road because they only remain their service for a short period and are subjected to low traffic volume. Unpaved roads are structurally supported by layers of sand or base aggregate placed over the subgrade without the bituminous wearing cost. So, unpaved road is the road with the low number of vehicle on it. So this is the problem statement. So in this study, the problem statement is Indian road comprised of the rural road, and it is estimated that 46.2% of the total road network are unpaved road. Next, the major issue related to the rural road are most of them are constructed in the weak subgrade. Next, even though the traffic flow is low, the proximity of this road are to the agriculture field, poor drainage system, and infiltration of the rainwater through the comparative porous surface finish soften the subgrade, which cause large deformation or rutting along the wheel path. Next, the loss of macadams into the soft subgrade through the mud pumping will reduce the necessary minimum thickness of the subbase or base course layer, accelerating the rutting phenomena. For the solution, pavement performance of the unpaved road can be improved with the inclusion of the geosynthetic. It is a quick and easier solution compared to the traditional alternative due to the ease of installation. So geosynthetic reinforcement is placed at the base or the subgrade interface to improve the road performance. This technique is partially effective because it reducing the permanent rut deformation for a given number of axle load. The goals of the geosynthetic reinforcement are to increase the road service life, reduce the construction cost by reducing the base layer thickness, a decrease of the time required for the construction, and of the periodic maintenance intervention. Okay, for the application. Normally, in unpaved road are using geosynthetic such as geogrid, geotextile. Moreover, geocell are also used, but to a limited extent. Next, in this study are more focused the use of the geogrid as the reinforcement. This is because the geogrid interlock with the aggregate to minimize the lateral movement of the aggregates, particles, and increase the modulus of the base course. Next, this will help to produce wider vertical stress distribution over the subgrade and reduce the vertical subgrade deformation. The degree of interlocking depends on the relationship between geogrid aperture size and aggregate particle size. The effectiveness of interlocking are not depends on the in-plane stiffness, which is more than strength of the geogrid, and on the stability of the geogrid ribs and junction. At a small permanent deformation magnitude, the lateral restraint mechanism is developed by the ability of the base aggregate to interlock with the geogrid. Next, the tension membrane will develop when the permanent deformation increases. If the geosynthetic has a sufficiently high tensile modulus, tensile stress will be mobilized in the reinforcement, and a vertical component of this tensile membrane resistance will help to support the applied wheel load. Next, there are two main reinforcement mechanisms, which is lateral confinement effect, and the tension membrane effect. They require different depth value of rutting in order to be mobilized. At small permanent deformation magnitude, the lateral restraint mechanism is developed by the ability of the base aggregate to interlock geogrid. Next, as increasing of the permanent deformation, the tension membrane mechanism is developed. If the geosynthetic has a sufficient high tensile modulus, tensile stress will be mobilized in the reinforcement, and the vertical component of this tensile membrane resistance will help to support the applied wheel load. Okay, next is the result. For the fixed design condition, when increase in the unreinforced and reinforced base aggregate thickness with increasing number of vehicular load cycle and with decreasing geogrid mechanical properties. Next, the higher improvement offered by the reinforcement in terms of the reduction of the reinforcement base layer thickness, the result also confirmed that there is higher efficiency when the reinforcement is placed at the base substrate interface has a higher mechanical properties. Consequently, benefit in terms of saving aggregate materials need for the base layer construction. For both proposed design method, the aggregate base thickness increase with the increase of rutting, and all the depth value of rutting chosen are larger enough to let the geosynthetic layer work, providing a reinforcement support proportionally to own mechanical characteristics. So this shows that better reinforced base performance is mainly due to the lateral restraints of the base soil, which develop for more reduced rut depth. When increased rut depth, the membrane mechanism required high value of geosynthetic deformation to be achieved. At equivalent traffic capacity and serviceability condition, geogrid benefit increase with decreasing subgrade mechanical properties and with the use of stiffer geogrid. Elastic modulus is very important because it governs how vertical stress are distributed on subgrade and consequently the amount of vertical subgrade deformation developed. For the conclusion, in conclusion, the reinforcement of the subgrade with the geosynthetic is most effective way of the constructing the unpaved road in the weak subgrade. This geosynthetic will improve road service for a long period. The application of geogrid geotextile is recommended in the unpaved road where there is low traffic volume, such as rural roads. This is the reference for my study. That's all. Thank you.